Okay, let's take a look at Achieve section 3.3, number 13. You're given this function here or something like it. And you've got x to the 3/2 power in this case, and then an expression. You've got exponents that are, fractional, some negative exponents, so a little complicated, but something that I would suggest very highly is if you can simplify an expression and you're allowed to do so. This section is, of course, with the product and quotient rule. You can actually distribute x to the 3/2 through and simplify that expression and avoid the product rule. Okay, now if you're told that you cannot use the product rule, obviously you have to do that. I will show you here in a minute compare using the product rule, so you could use the product rule, but it's much more tedious and time consuming. In general, if you can, which unless you're told otherwise, you can just simplify the expression first and then simplify, and that's what you should do. So I'm going to distribute this through. X to the 3/2 times 2x to the 6 becomes 2. It comes x to the 15/2. How do we get the 15/2? Remember, when we're multiplying like bases, we add the exponent. So 3/2 plus 6. 3/2 plus 6 is 3/2 plus 12/2, which is 15/2, or 7.5. Okay, so that's x to the 15/2 power. And then here we got x to the first power times x to the 3/2 to the first power is 2/2. And so I get x to the 5/2, or 2.5, right? And of course your coefficient -9. And then notice here, x to the 3/2 times x to the -1/2, 3/2 plus a -1/2 is just +1. You get x to the first power, which is just x. Hey, and now this is the same function as I started with, and there's no product rule. I just use the constant multiple, sum, difference rule, and of course the power rule. So those are the basic ones for finding the derivative of, say, any polynomial or any expression like this. So the 2 is a constant multiple, pull that out. And then x to the 15/2, power rule, I'll bring the 15/2 down, right? X to the subtract 1 from 15/2 is 13/2, right? Subtracting 1 in this case would be 2/2. 15 minus 2 is 13. So 13/2. And then I have the 9 is a constant multiple. Bring the 5/2 down. Subtract 1 from 5/2 gives me 3/2. And then x derivative is, of course, just 1, right? It's a line of slope 1, derivative is 1. And just clean this up, 2 times a half gives me, or 2 times 15/2 just gives me 15, x to the 13/2 minus, well, here I can't do any simplifying, but 9 times 5 is 45/2, or I guess that's 22.5, 45/2 times x to the 3/2 and then plus 1. And this is the derivative, and you're done. And there's no product rule at all in here. And so just because you know the product rule doesn't mean you necessarily have to use it or even want to use it. Let me just show you real quick how this looks with the product rule. If I were to straight up not do any simplifying and just use the product rule, then I would take, I've got this function here times this function here. So I take the derivative of this function. Okay, that's pretty easy. 3/2, right? Power rule, bring the 3/2 down. X to the what? Subtract 1 from 3/2, 1/2 power. Times all of that function, right? Plus the x to the 3/2. And then I have to take the derivative of what's in here. So 2x to the 6th power, that's pretty easy. Bring the 6 down. 2 times 6 is 12. And then subtract 1 from 6, x to the 5th, 12x to the 5th. Derivative of -9x is just -9. And then here, power rule again, bring the -1/2 down, -1/2 x, subtract 1 from -1/2 gives me -3/2. Okay, and there I've taken the derivative, but now we got to simplify. So guess what? I've got to distribute just like I did up here, but I have to do it twice, right? I have to distribute twice. Now, doing that, you might want to stop this and confirm this video. I'm not going to go through all the details, but if I multiply it all out, I get this. And then combining like terms, we finally get to the same answer that we got up here. So getting the same thing. So this is not wrong, but it's just right? So there's a little bit more involved. Not bad, but again, trying to learn these techniques. Keep in mind, if you can simplify a function before taking the derivative, do so. And I encourage you to, maybe even try problems like this, doing it both ways, just like I've done here, just to get a feel for it and see, what's a little bit easier. So the more derivatives you take, the better you're going to get. We're moving through now into these derivative rules. And so we want to practice as much as possible. Okay, so again, this is problem number 13 from the Achieve in section 3.3. I hope that's helpful for you in this one.